Hello students, welcome to the amazing platform of Physics Wala. Welcome to the PW English channel, my dear students. Today we are going to start another chapter, which is solid state. Today we are on the lecture 1 of solid state. Let me tell you, this chapter is actually very important. You might have studied states of matter in your 11th class, where you studied mostly about the gaseous state. After that, my dear students, we did study in 12th, we did study about solutions, that is the liquid state. And now we are going to discuss about the solid state. This chapter is very interesting. You only need to have a good imagination for understanding this particular chapter. It is super interesting. In fact, you can apply all the topics which we will be discussing here in your day-to-day life. Whatever we see around are either in solid, liquid or gaseous state. We'll be understanding the solid state, why particular shapes are given, how do we classify solids, and much more. So I hope all of you are excited. So let's start the amazing session today. What are we going to discuss? We'll be first, before that, let me tell you the beauty of chemistry, my dear students. In fact, chemistry is everywhere all around you. Chemistry is in chocolate. The chocolates you eat is actually the chocolate formula has chemistry in it, right? Yeah. If you talk about caffeine, the coffee you drink or the tea you drink, what is there? Chemistry is present there. Happiness, in happiness there is chemistry. In fact, everywhere all around you, it is, each and everything involves chemistry. So this is the beauty of chemistry, and that is the most important part, right? Yes. So I hope all of you are in love with chemistry, because I am in love with chemistry. And with this pure thought, let's start the session. So let's discuss about solid state. So my dear students, the first question that should come into your mind is, what is matter? What is matter? Matter is anything that occupies space and has mass. This is the basic definition you have studied, right? Yes. So let's write this definition first. What is matter? Anything that has mass and occupies space. What is matter? Anything that occupies space and has mass is matter. Let's talk about this. This is a pen and it has mass, it occupies space, it is matter. Similarly, liquid state, water in a bottle actually has mass and it occupies some space, so it is matter. In fact, the gas around us is also matter. So anything that occupies space and has mass is known as matter. So if we talk about matter, then matter can exist in various different forms, right? So let's discuss about that. If we talk about matter, my dear students, matter majorly can be in any type. Matter can be in solid state, it can be in liquid state, or it can be in gaseous state. There are other states as well. There are n number of other states as well, my dear students. But in our syllabus, we are going to only discuss about these three main states. Okay. Yes. And also, you might have studied about the gaseous state in class 11th. You have studied in chapter 2, class 12th. Solutions, and now we'll be discussing chapter 1 of class 12th as solid state, right? Yes. So this is what we are going to discuss today. So I hope all of you are excited. If you want to write it, you can write it, and then we'll move forward. Okay, so now my dear students, after understanding this particular part, I hope all of you, we actually started the solutions chapter, and in solutions chapter, I gave you an answer to why particular things belong in the solid state, why particular things belong in the liquid state, and why in gaseous state. We discussed about the thermal energy concept and the those force of attraction concept, right? Yes. So I hope all of you remember that, because that that is the most important part, my dear students, that we have already discussed. So I'll not discuss it again. You can go through the solutions first chapter and go through all those basic points which we discuss in solid state. Sorry, in fact, in any state of matter, we first discuss that particular part and then move forward. Okay, since I have discussed that in solutions chapter, so I am not discussing here why a particular compound is sometimes in solid state, why in liquid state, or sometimes in gaseous state. The reason behind each and everything, why volume is fixed, why shape is fixed, all the questions are answered to you in the solutions chapter 1. So you have to go through that. Okay, yes, I hope it is perfectly clear. Now, my dear students, let's start the solid state. Let's start the solid state. So my dear students, if you talk about solids, we majorly divide solids in two important parts. Solids can be classified either as crystalline solids or as amorphous solids. They can be classified either as crystalline solids or your amorphous solids. Now you need to understand the basic difference between these two. Okay, so to understand this and to move forward, I just want to tell you one thing. From now on, whenever a crystalline solid is said, a picture should emerge in your mind, and that should be for a diamond. Okay, whenever somebody says crystalline solid, it should be clear that they are talking about a diamond. Okay, this is somehow you'll understand each and every part if you get this picture in your mind. Okay, first thing, let's talk about the other thing. If anywhere you listen to a word which is amorphous solid, then for amorphous solid, always and always a picture should emerge in your mind, and that is for a eraser. I hope all of you know the eraser which we use with we write with a pencil and we erase with a eraser, right? Yeah, so these are the two things that should emerge in your mind whenever these two words are used: crystalline and amorphous solid. Okay, if you are clear with this, then we can move forward and we'll understand each and every part very easily. So what generally questions are asked is, what is the difference between what is the difference between crystalline solids and amorphous solids? So there are a lot of differences between them on the basis of their arrangement, on the basis of their uh, melting point and boiling points, on the basis of their isotropicity. So we'll be understanding each and every part very, very quickly and very easily. Okay, yes, but these two pictures should emerge in your mind. Okay, yeah, perfect. If you want to write it, you can write it here, eraser. If you can't draw the drawing, and write it here as diamond. Okay, now let's move forward. Okay, perfect. So now my dear students, I just want to tell you that the first classification is on the basis of arrangement. The first classification is actually on the basis of arrangement. Okay, yes, so let's try to understand arrangement of amorphous and crystalline solid. Okay, see, now I told you that for a crystalline solid, always and always a picture should emerge, and that should be of a diamond, right? Yeah, and you know that diamond is too expensive. Yes, ma'am. This means that a lot of work is done to make a diamond. It takes a lot of time, it takes a lot of work to form a crystalline shining diamond, right? Yeah, but at the same point, if I talk to you about the eraser come out of nearly 2 rupees, 3 rupees cost, right? 5 rupees cost. Yeah, yes. Now if I talk about eraser, why are they so cheap? Why? Because a lot of work is not given to form one particular eraser, right? Yes, it can be formed in a very quick span of time, right? Yeah, this is something you can understand now. Since to a diamond you need a lot of time and work, for a eraser you don't need that much time. It is generally made with the machines, and you don't have to give your extra effort to it, right? Yeah, that is why its cost is also very less, right? Yes, so now a thing which requires a very large amount of work, obviously its arrangement would be something very ordered, beautifully arranged, right? right? Yes, because many people are working on that particular part. It is taking a lot of time, then definitely its arrangement will be very beautifully done, very ordered, in a very ordered way, right? Yes, and that is how you will understand the crystalline solid on the basis of arrangement. Since crystalline solids are diamonds and diamond requires a lot of time, this means that the arrangement also is very beautiful, very ordered, very systematic, and that is what is crystalline solid. On the basis of arrangement, your crystalline solid has a ordered arrangement, or you could say long range order. I'll just make you explain the difference. Now try to understand why I said it is a long range order. Okay, so since I am saying it is a long range order, this means that, my dear students, if you see the interaction between this particular particle and this particular particle, they are at equal distance from each other, at a particular distance from each other. Let's take the same two particles, let's take this and this, they are also at the same distance from each other. Similarly, if I talk about this particle and this particle, they are also at same distance, this particle and this same distance, this and this same distance. So I can say that the particles are at equal distance from each other. Now, since they are placed at equal distances, obviously the forces of interactions between them are also equal, right? They are also equal. They are not like somebody is very far away, somebody is very closer. No, the arrangement is ordered. It is ordered and it is same. You see here between two particles, or you see after 10,000 particles, the order is exactly the same. The force of interactions are exactly the same, and that is the reason it is said long range order. Long range order means the distance between the particles, the arrangement which we can see here, will be exactly same after 10 particles, after 15 particles, after 1,000 particles, and that is the reason we say that it is a long range order. Okay, similarly, let's talk about now amorphous solids. See, since for a long range since for a amorphous solid you don't require a lot of time, eraser is of very minimum cost, right? Yes, so eraser doesn't need a lot of work to do, then its arrangement will also not be very beautiful or very ordered way, right? Yes, it will be a little disordered way, and that is what happens for a amorphous solid, my dear students. In an amorphous solid, though there is arrangement, but the arrangement is not exactly same. If you see here, I can say that this particle and this particle has this much distance. Now, if I tell you, let's take an example of this particle and this particle, there is a little lesser distance. If we see this particle and this particle, there is a large distance between them. This means that the particles doesn't have the same type of arrangement. It might be that the arrangement of the particles here and after 5 particles are also same, but after 10 particles it definitely will change. This means that it has the same arrangement closer, but it doesn't have the exactly same arrangement if you see after 10,000 particles, right? Yes, so for amorphous solid, we say that it is a short range order. For amorphous solid, it is a short range order because the arrangement is ordered only at a very short range and not at a very long range. Yes, and we can understand this by the example of eraser and the diamond, right? Yeah, perfect. I hope you're clear. This question is generally asked, so please, you can write it. You don't need to draw the complete diagram, but try to write this, that the arrangement is not same at a long range. So that is why it is known as short range order, and it is ordered in the whole range. So that is the reason they are called the long range order. Please write it and then we'll move forward. Okay. I hope you've written it. Let's move forward. Now you can see this, and if you want to understand the difference between crystalline and amorphous solids arrangement, you can see it here. Since we talk about the crystalline solid, there is a ordered arrangement. Just see, you might have eaten this, right? Yeah, you all like corn, right? Yeah, so see, In corn, we see this particular part, the upper part, which is in ordered arrangement. So this is crystalline. And if we see the bottom part, this is very disorganized. And that is the reason it is something like amorphous solid, right? Yeah. So we can say that this is amorphous and this is crystalline. Now you will never forget. Always remember this. Perfect. Now let's move forward. Next is, my dear students, on the basis of a melting point. Many a times you can differentiate between crystalline solids and amorphous solids on the basis of melting point. Now, since you know that in crystalline solid, the arrangement is ordered, the particles are at equal distance from each other at all the ranges, right? Yes, but for amorphous solids, somewhere particles are very closer to each other, somewhere particles are very far apart to each other, right? Yes. So now you'll understand the difference, my dear students. If you talk about the melting point actually depends on the force of interaction. The more the force of interaction, the lesser will be the higher will be the melting point, because since the interaction is strong, then you need a higher temperature for the bond to for the bond to break, right? Yes, and then only you will get the melting of the solid, right? Yes. So this means that the closer, the ordered the arrangement, the melting point will be high. See, if I talk about the crystalline solid, I can say that the arrangement is exactly ordered, right? Every interaction is exactly same, right? If I think of a temperature, my dear students, then since the interactions are exactly same, then the forces of interactions strength will also be same, and at one particular temperature all the interactions will melt at the same time, right? They'll not need variation of temperatures, they'll need only one particular temperature where all the interactions, since they are equal, they'll break together and you will get the melting point, right? Yes. So we can say that we have sharp melting point here. We have sharp melting point here. Why we have sharp melting point? Because the forces of interactions are exactly equal, right? You can say that forces of interactions are equal. Because the forces of interactions are equal, that is the reason they are known as crystalline solid. They have a sharp melting point. Now let's come to the amorphous solid. If you see, for amorphous solid, somewhere the particles are very closer to each other, their forces of interaction will be very strong. Somewhere the particles are far apart from each other, then their forces of interaction will be very weak. Now if we try to increase the temperature and melt them, they'll not melt at one fixed temperature, because the strength of forces of interactions are not equal. They'll actually melt at a range of temperature. Some will melt, let's say, some will melt at 300 degrees Celsius, then some will melt at 302 degrees Celsius, some will melt at 301 degrees Celsius. So there is no sharp melting point because the interactions vary. There is a range of melting points. So we can say that melts over a range of temperature. So it has a range of melting point. So it has a range of melting point. It doesn't have a sharp melting point. I hope you're clear with this. Everything is related to their arrangements. Okay. Yes, you can pause the video, write it, and then we'll move forward. Okay. Now let's move forward, my dear students. Now we'll be discussing a very important topic, and that is the difference between the two on the basis of isotropicity. So you can mark it as important, because question is generally asked from this particular part, See, now we talk about the isotropicity. So my dear students, what is isotropicity? You might have heard, first let me give you an example. Okay, imagine you are standing in an assembly. Whenever you were standing in an assembly, I hope all of you remember that whenever you stood in an assembly, you always had to stand in a straight line. You always had to stand in a straight line, right? Yes, you always had to stand in a straight line. So that was a kind of ordered arrangement. Now consider this as a very high amount of crowd, and they are not sitting or standing in an arrangement. They are, let's say that this is a mela, this is a fair, Okay, this is a fair there where there is a random amount of crowd going around randomly. They don't have any order, they are not in specific lines. Okay, now what will happen? See, if you are standing here and you go from here to this side, you will see that you will not bump into any child because the order is arranged and you are moving in a line where no student is standing. But if you go from here, my dear students, then you will bump into many children. You will bump into many children. You'll have to leave them aside and then you'll have to go. This means that the point where you are changing your direction, your atmosphere is changing. First, you didn't find any child, but in the other direction you found many children, right? Yes, you bumped into many children. But if you talk about a crowded area like this, a random area, let's say, or you could take an example of any fair, any mela, if you might have gone to a Chandni Chowk in Delhi, you might have seen there is high amount of crowd, okay, and everybody is going randomly somewhere or the other, and you just bump into people again and again. So let's imagine you're standing here. If you'll see here, you'll get random people. You'll see here, you'll bump into people. You'll go here, you'll bump into people. You go anywhere, you'll bump into people, because this is a random arrangement. This means that in this particular part, you go to any direction, you will get the same atmosphere, and that is bumping into people, right? But if you change your directions here, you might get a different atmosphere. Sometimes you will bump into people, but sometimes you will not bump into people, right? Yes. So now I'll make you explain what is isotropicity. There are a many large amount of properties which actually depend on the direction, right? Yes, and they change their values as the direction, as the atmosphere changes. Okay, so my dear students, in crystalline solids, properties do change their values depending on the direction, because they experience different atmospheres. But if you talk about amorphous, since the arrangement is random, the properties have the same value in all directions. They have the same value in all directions because they get almost the same atmosphere, right? Yes. So amorphous solids are isotropic in nature. Amorphous solids are isotropic in nature, and crystalline solids are anisotropic in nature. This is the biggest mistake, because since it is arranged, so most of the students who tick the answer for the crystalline solid is isotropic, they think that is isotropic, but no, it is anisotropic, because it is ordered, and that is the reason it is giving different values. Okay, yes. So I hope you understood the basic meaning of isotropicity. Okay, amorphous solids are isotropic in nature. The value of various properties is the same, since the atmosphere is same in all directions, but for an ordered arrangement, the atmosphere is different, and that is the reason values come out to be different. Okay, yes, I hope you're clear with this. Write it down and then we'll move forward. Okay, now see, this is your amorphous solid, this is your crystalline solid. Now in crystalline solid, since the arrangement is different, since the arrangement is ordered, if you will go from A to B, my dear students, you will get black lines here and white lines on the other side, right? Yes, so the atmosphere here is different. But if you go from C to D, my dear students, you will see that you will get one white, one black, one white, one black, white, black atmosphere, and from here also you will get white, black. This means that you change your direction, your atmosphere changes, and since the atmosphere is changing, the values of the atmosphere is different, and that is the reason values will be different for those properties. But if we talk about the amorphous, you go from this side to this side, you go from here to here, the atmosphere is exactly same, because it is random everywhere, and that is the reason properties have exactly the same values, and that is why it is isotropic and it is anisotropic in nature. It is written here, same disorder on both the sides, measuring in different directions, hence amorphous solids are isotropic in nature, and your crystalline solids are anisotropic in nature. right? Yes, it is a very important thing because most of the questions are asked from this particular part, so I'm stressing on it again and again. So pause the video, you can write it, and then we'll move forward. Okay, now let's move forward. The next arrangement is actually on the basis of cleavage. The next arrangement is actually on the basis of cleavage. Now see, imagine you are sitting in your class. Imagine you're sitting in your class and you're talking to your friend and he's your best friend, okay? And he forgot to bring his eraser. But it is a test and he needs a eraser. What will you do? You have one eraser, you'll just break it half and you'll give half of your eraser to your friend, right? So if you talk about your friend's eraser, you'll have something like this. The eraser would break something like this, right? Yes. Will it be will it break evenly? No, you'll have some bumps in it, right? Yeah, because my dear students, since the arrangement of amorphous solid is disordered, so when you break it or when you cleave it, it is not a smooth cleavage. It is not a smooth cleavage, okay? You get bumps in it because of the disordered arrangement. I hope you get this now. Now let's move forward to a crystalline solid. Now my dear students, you know that in crystalline solid the arrangement is absolutely ordered, and if you cleave a crystalline solid, let's say you cleaved this from here, what you will get? You get a plain smooth area. You will get a plain smooth area because the arrangement is ordered, right? Yes, this is the difference between the amorphous and crystalline solid based on the cleavage. So can I say that here you will get a smooth cleavage and here you will get a rough cleavage? Right? Yes. I hope you got the reason behind it, because there is a ordered arrangement in the case of crystalline and not a ordered arrangement in the case of amorphous. Okay. Yes. You can pause the video, write it, and then we'll move forward. I hope you've written it. Now let's move forward, my dear students. Now, this is how you classify a solid as amorphous or crystalline depending on its properties, right? Yes. Now let's try to understand a little bit more crystalline versus amorphous solid. So now, my dear students, if we talk about the solid state and the liquid state, we call it as the condensed state of matter. We call it as the condensed state of matter. We call it as condensed state of matter. Okay. Yes, perfect. Next, if we talk about the liquid and gaseous state, these are, my dear students, known as fluids. Why are liquid and gas called fluids and not solid? Because liquid and gas, these are the two states of matter which have the tendency to flow, right? Yes. So we can say that they have the tendency to flow. I can say particles have the tendency to flow, okay? Particles have tendency to flow. And that is the reason these two together are known as fluids. Okay, perfect. I hope you've studied in your physics also. You call liquid and gas both as fluids, right? Yeah. Now, my dear students, if you talk about the amorphous solid is also known as, amorphous solids are also known as, now see, solids is condensed state of matter. It is not a fluid. It does not have a tendency to flow. But your liquid and gas has the tendency to flow. Okay. Now, amorphous solids are also known as pseudo-solids or supercooled liquids. Now, this is something important, and from here generally question is asked. So now let's try to understand what does this mean. So my dear students, since amorphous is a solid, then ma'am, why are we calling it a liquid? Why are we calling it a super cool liquid? Now I'll make you explain this, my dear students. Now when you talk about the solids, and especially the amorphous solid, a big example of amorphous solid is, my dear students, glass. The glasses which we see on the window panes or the buses windows where we see the glasses, all those glasses are the example of amorphous solids. Okay, now you need to try to relate it. Okay, you might have visited any place which is nearly 50-100 years old. Okay, in Rajasthan, where there are a big there is a museum. If you see some museum or you visit a very historical place, what you will see, those the window panes of the glasses are a bit thicker from the bottom and thinner from the upper side. Why is this so? You see something like this. The window panes are like this, and they are thicker from the bottom, and then they are thinner comparatively to the upper side. Why does this happen, my dear students? Now glass is a glass and it was not made like this. Then how is it thicker from the bottom? Actually what happened is, my dear students, your glass with time, though we cannot see it with our naked eyes, but it has a tendency to flow. Very little tendency, it flows very slowly, we can't see it. But the glasses, that is your amorphous solid, has the tendency to flow very slowly, and over the duration of 100-200 years, what happens is the particles keep on flowing, and you get a thicker part down, and the upper part becomes thinner. And this is the tendency of an amorphous solid. This is the tendency of a solid to flow, and that is the reason we say that amorphous solid is a super cooled, highly cooled liquid, because it has a tendency to flow. So definitely it has some properties of a liquid, so we'll say that it is something very super cooled liquid. Okay, one name is this, and the other is pseudo solids, because it is a solid. Amorphous is a solid, but it is not behaving like a solid, right? Yes, it is a fake solid. That is the reason pseudo means fake. Okay, and that is the reason we call amorphous solids as pseudo solids, fake solids, because they are violating the definition of a solid, because solid is condensed state, it doesn't have a tendency to flow, but yet amorphous solid flows, and that is why it is given these two names. And you are asked a question that what are the other names with which amorphous solids are known, or you might get these names and asked and they ask you any other question. That is the reason you need to know these names. Okay, perfect. I hope you're clear. Pause the video, write it, and then we'll move forward. Now, let's just check it out. What does this mean? When you tell a chemistry enthusiast that glass is a solid, no, it is not a solid, he just gets angry. Why does it get angry? Because, my dear students, it is not a solid, it is a super cool liquid. It has a tendency to flow. Now you'll never forget it. Yes? Yes, perfect. Let's move forward. Now, my dear students, I just want to ask you a question. Let's say I said that whether carbon is crystalline or amorphous. Now, if somebody asks you, can you tell me whether carbon is crystalline or is it amorphous? How will you answer it? Can a particular element be crystalline or amorphous only, or it can be both? Now you will get the answer to this question. Let's see the answer. Answer is in the next slide. The next slide says that carbon, a particular element, can both be amorphous or crystalline. If the arrangement of that is ordered, we give time to it to form a ordered arrangement, it will form a crystalline solid. If we don't give it that much time, then it will be a disorganized arrangement, and this will be an amorphous solid. Okay, so it can be amorphous, it can be crystalline. You have examples of that as well. Your diamond is actually made of carbon, but since it takes a lot of time, then it is a crystalline solid. The graphite that we use in our pencils, That is also an example of crystalline solid. But if you talk about coke and coal, my dear students, coke and coal are made of carbon as well, but they are amorphous in nature because the arrangement is not long range order, because the arrangement is not ordered, right? Yes, this is the best answer you can give, that a element can both be amorphous and crystalline. It only and only depends on the arrangement of that particular element. Okay, yes, perfect. I hope you're clear with this. Pause the video, write it, and then we'll move forward. Now, my dear students, I want to ask you a question, and this will be a homework question. No, not homework question. I'll just explain you right now, but try to answer me in the comment section before I give you the answer. Can SiO2 be crystalline or amorphous? Is it crystalline or amorphous? Okay. So now, my dear students, again, the answer exactly remains the same. SiO2 can be both crystalline and amorphous. It can be crystalline. It can be amorphous. If it is crystalline, it is in the form of quartz, only quartz, okay? And if you talk about amorphous, then it is quartz and write a glass in front of it. Quartz, glass. Whenever you see a glass, you just write it, it is an amorphous solid, okay? I hope you're clear with this. Perfect, my dear students. Pause the video, write it, and then we'll move forward. Oh, you got the answer here, right? Yes. If you want to draw it, and then we'll move forward. I hope you've drawn it. Now let's move forward, my dear students. Now, let's take a few examples of amorphous and crystalline, and now your life will be easier. Okay, so now if I say, I am writing here amorphous, and here crystalline. So what are the examples? Okay. So my dear students, let me tell you, 99% of the solids are crystalline in nature. 99% of the solids in the universe, atmosphere, in the world are crystalline in nature, and only a few are amorphous. Okay, so if we learn the basic solids which are amorphous, rest all will be crystalline. So you need not remember these, but you need to remember this. Okay, so my dear students, if you talk about amorphous, then rubber, any form of rubber, any form of glass, any form of polymer. You will be studying polymer in 12th organic as well. Okay, any form of polymer. Plastics are polymers, cellophane is a polymer, Teflon is a polymer, okay, and many more which you will study. So don't worry, you will study and you will know which of the following are polymers. Only and only these are amorphous, rest all are crystalline. Only and only these are polymers, rest all are crystalline. Example, your NaCl, your benzene, argon, all etc. are your crystalline in nature. Okay, so you only need to remember these. These will be, the rest left are your crystalline in nature. Okay, so I hope you're clear, and this is the most important part. You need to learn these examples. Only then you will be able to solve the questions. Okay, so pause the video, write it, and then we'll move forward. Okay, so now my dear students, a question is generally asked, and it is a very good question as well, that how can you convert a amorphous solid into a crystalline solid and vice versa? How can we convert, or can we convert or not? That is a major question. Yes, we can convert an amorphous solid to a crystalline and crystalline to a amorphous. We only need to make the arrangement ordered. Okay, we only need to give it some time. So how are we going to do? See, let us say you have an amorphous solid. Okay, I'll write it here. Let's say you have an amorphous solid. So what you need to do is, just heat it. Heat it, right? You'll I'll write it here like this, okay? You'll heat it, and when you'll heat it, you'll get it smelt. That is, it will melt, right? Yes. Now what are you supposed to do in order to convert the amorphous solid to a crystalline solid? I told you the arrangement should be ordered, and for a ordered arrangement you need time. So what are you going to do? You are going to slowly cool it. You're going to slowly cool it. So slow cooling. And when you will do slow cooling, my dear students, you will get a good amount of time for the particles to arrange in order, and you will get a crystalline solid. Now let's say you have a crystalline solid, and you have to convert it into a amorphous solid. How will you do? Again, ma'am, since it is a solid, we'll have to melt it down. So again, we'll have to heat it. After heating, you will get melt. Now, my dear students, you want to convert this melt into a amorphous solid, and in amorphous solid, the arrangement is not ordered. You need not give the particles time to get arranged. You need to do fast cooling. So in this particular case, you will do fast cooling, so that the particles don't get enough time to be arranged, and after fast cooling you will get your amorphous solid. So this is how you can interconvert both of them. Okay, you need to understand this. If you want to write it in your words, you can write it otherwise in the flowchart you are understanding it very clearly. So I hope you're clear with this. Pause the video, write it, and then we'll move forward. Okay, perfect. Now, my dear students, let's try to use whatever we have learned till now in some questions and revise all the concepts. Okay, so the first question is, which of the following is the only incorrect statement regarding amorphous solid? Which of the statement is incorrect regarding amorphous solid? The first is, on heating they may become crystalline at some temperature. Yes, if you heat them and slowly cool them, then definitely they can be converted in crystalline solid. So this statement is correct. They may become crystalline on keeping for a long time. Yes, they may become crystalline if you keep it for a long time. Absolutely right. Amorphous solid can be molded by heating. Yes, you can mold them by heating. That is also true. You can melt them, and then you can mold them in any form you want. Okay. Last is, they are anisotropic in nature. Are your amorphous solid anisotropic? If it is amorphous, it means that arrangement is not ordered. If the arrangement is not ordered, this means that we are talking about a crowded area, and in a crowded area the atmosphere is same in all directions, so the value should be same, and since the value should be same, it should be isotropic in nature and not anisotropic. So this is a wrong statement. Option D will be your correct answer. This is how you will be solving these types of questions. Perfect. I hope you're clear. Pause the video, write it, and then we'll move forward. Next question. Which of the following is called a pseudo solid? Now the question is, which of the following is known as a pseudo solid? So if we talk about a pseudo solid, my dear students, then I know that pseudo solid means fake solid. It is a fake solid. Who is a fake solid? Amorphous solids. So ma'am, amorphous solids. Now, if it is an amorphous solid, this means that, can I say that any glass, rubber or polymer will be a amorphous solid? Let's take the example. NaCl is not a glass. It is crystalline. It is crystalline. Diamond is a crystalline solid again. Glass, it is a amorphous solid. Silicon carbide will again be a crystalline solid. I said you only need to remember the amorphous solids example. Rest all will be your crystalline solids. So you're clear with this? Perfect, my dear students. Please write it down, and then we'll move forward. I hope you've written it. Let's move forward. Next is you have to classify each and every one of them as amorphous or crystalline solid. Okay, so pause the video, try the question yourself, and then we'll move forward. I hope you've done it. Now let's try each and every part. Now, my dear students, if we see, the first part is polyurethane. Okay, so for polyurethane, what can you say? So for polyurethane, my dear students, I just want to tell you, if to any solid's name you see this poly word, just understand that it is a polymer. And since it is a polymer, I can say that it is amorphous in nature. I can say it is an amorphous in nature. Okay, this is a trick to find out whether it is a polymer or not. The next is naphthalene, my dear students. Naphthalene. Now, naphthalene is a crystalline solid because it is neither a glass nor a rubber nor a polymer. So, it is crystalline in nature. Let's write it down here only. Okay. If we talk about benzoic acid, again, it is neither a glass nor a rubber nor a polymer. So, it is crystalline in nature. Is it visible? No, it's not visible. I'll use pink pen. It is crystalline in nature. If we talk about Teflon, I gave you an example. It is a polymer, my dear students. So it is amorphous in nature. Let's talk about potassium nitrate. It is again a crystalline in nature because it is neither rubber, polymer or glass. If you talk about cellophane, I gave you the example. It is again a polymer, my dear students, so it is amorphous in nature. If you talk about polyvinyl chloride, a poly word is coming. This means it is a polymer, so this is also amorphous in nature. If you talk about fiberglass, glass is coming. This means that it is a glass, so it is a amorphous in nature. Copper, again, my dear students, no rubber, no polymer, no glass, so it is crystalline in nature. So this is how you can classify whether it is an amorphous solid or a crystalline solid in just few seconds, right? Yes, I hope you're clear. This is the trick to find out. If you see poly word, that means it is a polymer. If you see glass at the end, it is a glass and amorphous solid. Write it down and then we'll move forward. I hope you've written it. Perfect. Let's move forward. Now, try to read the question and write the answer on your own. After that, I'll definitely help you out. The question says that refractive index of solids observed to have the same value along all the directions. Comment on the nature of this solid. Would it show cleavage properly? Properly, yes. Now just see. Property. Okay, it's fine. See, since refractive index of a solid observed have the same value, since the value is the same in all directions, if the value is the same in all directions, this means that we are standing in a crowd and we go in any direction, we'll see the same atmosphere. This means that where is this crowded area coming from? It is coming from the amorphous solid. The ordered arrangement is not present, so the solid is amorphous solid. I just got my answer. It is amorphous solid. Now, my dear students, the first question we've answered the nature of the solid. It is a amorphous solid. The other question says that would it show cleavage property? Again, my dear students, since the arrangement is not ordered, if you will cut it down, if you will cleave it down, you will not see a smooth cleavage. You will see a rough cleavage, right? Yes. So we can say that no, it will not show smooth cleavage. So it will not show smooth cleavage. Okay, this is how you have to solve the question. So easy, right? Yes, perfect. Let's move forward, my dear students. Write it down. Next question. What makes a glass different from a solid such as quartz? How a glass is different from quartz? Okay, then you have to tell under what conditions would quartz be converted into glass. So see, my dear students, if it is telling you quartz, what does quartz mean? SiO2. And what is quartz? It is crystalline in nature. We just discussed it. Okay, and if you talk about glass, then glass is amorphous in nature. So it is saying that what makes a glass different from a solid such as quartz? So basically you are asked to differentiate between crystalline and amorphous. So you are supposed to differentiate between crystalline and amorphous. So whatever we have studied today, you have to write all the points here. Okay. The next point is, how will you get converted into this? So you have to tell how you will convert crystalline to amorphous. How can you convert it into crystalline to amorphous, my dear students? By heating and then rapid cooling. Okay, so whatever is asked, whatever we have studied today, everything is asked in this one single question. So you have to answer this question on your own, and only then you will be able to revise all your part which we have discussed today. Okay, so pause the video, try to do it right now, only then you will understand everything. Okay, perfect. I hope you're clear with this now. Okay, perfect, my dear students. Let's move forward. Now we will be discussing the classification of crystalline solids. I told you that 99% of your solids are your crystalline solids. So since crystalline solids are 99% of all the solids we know, we need to study about crystalline solids. So now we will be discussing only and only about crystalline solids and not amorphous solids. So you can classify your crystalline solids in 4 major parts. You can classify your crystalline solids in 4 major parts. What are those 4 major parts? Let's discuss about them. First is ionic solids. The other is molecular solids. Then you have metallic solids. And then you have covalent solids. Okay, these are the 4 major types of solids that we will be discussing under the crystalline solids. These molecular solids can further be classified into 3 types. One is non-polar molecular solids. The other is polar molecular solids. And it is hydrogen bonded molecular solids. Okay. Yes. So this is how we classify the crystalline solids. Crystalline solids are classified into different types. And what are these different types? Why have they been classified into these different types? Because, my dear students, the solids which are present in crystalline, though they are ordered, but the force of interaction between the solids vary. Somewhere it will be very strong interaction, somewhere it will not be very strong interaction. So we'll be discussing about each and every type of solid, their force of interactions, whether they are good conductors of heat and electricity or not, and many more things. Okay, yes, so I hope you all are excited. So write it down and then we'll move forward. Okay, I hope you've written it. Now let's move forward. Okay. So now, my dear students, before this, we need to understand a little bit about the forces of interactions. You might have studied about the forces of interaction in your chemical bonding chapter, but you also would have forgotten all of that. I know that. I trust you. Okay. So now I'll make you explain. I'll make you remember or revise those forces of interactions. Okay. So, my dear students, the strongest force of interaction is your covalent bonding. Covalent interactions. Okay, covalent interactions are the strongest. Then you have ionic interactions, ion-ion interactions. Okay, then you have, my dear students, dipole hydrogen bond. Basically, you can say hydrogen bonding interactions. Okay, so you can say hydrogen bonding interactions. Then you have dipole-dipole interactions. And the last are your London forces. These London forces are actually present in your molecular solids. We'll discuss about them, just leave it here. So these are the interactions which you need to understand. Covalent interactions are very, very strong interactions. Ionic interactions are the next highest. Then you have hydrogen bonding, then you have dipole-dipole interactions, and then you have the London forces, right? Yes, these are the forces of interactions which you need to understand. We will be discussing the different types of solids and these interactions in them. Okay, yes, so please write it down and then we'll move forward. I hope you've written it. Now let's move forward. So see, my dear students, now you'll get a little bit of the idea about the interactions. So see, you might all have used these firecrackers in Diwali. Yes, you might have used this Diwali in Diwali, these firecrackers. You say no, I know you all. You haven't, you cannot stay without using these firecrackers. Okay, so we know that this is a very, very explosive as compared to these two. Okay, I don't have a word to describe this, but I know that when this bursts, a large amount of sound is produced. Okay, comparatively this is lesser and this is very, very lesser, right? Yes, so we can just classify them as, let's say this is ionic, this would be, let's say, hydrogen bonding, then this would be, my dear students, your London forces. You'll get the idea. You'll get the idea about the interactions. The weakest interactions, strong interactions. Covalent are strong. We are not discussing about that. But if we talk about these interactions, this is the highest, then hydrogen bonding, and then the London forces. So I hope you got the idea what I wanted to tell you. Okay, yes, perfect. Let's move forward, my dear students. If you want to write it and draw it on your own, you can just write it down. Okay. Let's talk about the first type of solid, which is ionic solid. Okay, so ionic solid is a very, very strong interaction between the solids. Let me start it again. Okay, so if we talk about ionic solids, my dear students, we need to know that what are the constituent particles of this solid, which force of interaction is taking place, and what are the examples. Okay, so let me give you the example first. Okay, so the examples of your ionic solids are, let's say, MgCl2. This is +2, this would be -1, or let's say NaCl, Na plus Cl minus. So the constituent particles for this particular solid are your ions. Ions are your constituent particles. So can I say that ions? Yes. So ions are your constituent particles. Okay. Or better to say oppositely charged ions. Okay. Oppositely charged ions. See, for MgCl2 you have Mg2 plus, then you will have Cl in negative. If you have Na plus, then Cl will be negative. So this means that you will have oppositely charged ions as your constituent particles. And if you talk about the force of interaction, which force of interaction is taking place? Ma'am, strong ionic interactions are taking place. So ionic interactions, and these are very strong. Okay, perfect. I hope you're clear till now. There is no issue till now. Okay, now if we talk about ionic solids, we need to know a few things about ionic solids. Okay, so ionic solids it is generally said that ionic solids are brittle and not but not malleable. So the first thing is ionic solids are brittle but not malleable. Now let's try to understand why ionic solids are classified as brittle and not malleable. If we talk about ionic solids, then let's say you have Na plus, then you will have Cl minus here, then you will have Na plus here, then you will have Cl minus here, then you will have Cl minus here, Na plus here, Cl minus, Na plus. This is how your ionic solids exist. Okay, this is the interaction between them. So if I want to make you explain this, can I say that you have something like this? You have a positive charge here, negative here, positive here, negative here, negative here, positive here, negative here, and positive here. This is a ionic solid. Okay. So how are they brittle? What does brittle mean? Brittle means that whenever a pressure is applied on a solid, it just breaks. Example, let's take the example of a what example should I take? Let's take the example of a glass. Okay, if we are talking about a quartz is also a glass, the crystalline form of quartz. Okay, so if you talk about quartz, my dear students, you see that whenever you throw a stone over it, a pressure is applied over there and it just breaks. I am just giving you an example of the brittleness. What is brittle? Whenever a pressure is applied, the solid will break into pieces. That is the brittle nature of a solid. Whereas if you throw a ball over a, let's say, if you throw a ball over a rubber band or a eraser, will it break? No, it will not break. If you throw a rubber over this, if you throw a ball over this solid, will it break? No, it will not break. It is not brittle in nature. So some solids are brittle in nature and some are not. Your ionic solids are brittle in nature. And why are they brittle in nature? I'll just make you explain. Now try to understand that I applied some pressure over this layer. If I'll apply the pressure over this layer, what will happen? You will have negative, positive, negative, positive. You applied the pressure over the above layer, my dear students. What will happen? It will move a little in front and you will have positive here, negative here, positive here, negative here. Now see, you have positive charges together. So these will, can I say that these will repel? And since they will repel, this will break into pieces, right? Yes. So that is the reason your ionic solids are brittle in nature. Your ionic solids are brittle in nature. What does malleable mean? Malleable means the tendency to get converted into sheets. You can convert them into sheets. So now, my dear students, malleability means a solid can be, if we apply the pressure on the solid, it will be converted into sheets. Can you apply pressure on this solid and convert it into sheets? No, we cannot do that because the interactions are very strong and they are immovable. They will not move. Particles cannot move here. They are very stable on their positions, right? Yes, and that is the reason you cannot convert them into sheets. So this is why ionic solids are brittle but not malleable. Okay. Next, my dear students, one more thing about your ionic solids is that ionic solids are good conductors in molten state and bad conductors in solid state. Now let's try to understand this. Okay, see, now my dear students, whenever you talk about the ionic solids, whenever you talk about the conductivity, how is a particular thing called as conductivity? You need charge carriers for that. If you have charge carriers, then a particular solid or a liquid will be conducting in nature. So what are the different types of charge carriers? Either you have free electrons or you have free ions. These are the two types of your charge carriers. So to carry a charge, for a solid or a liquid to be conducting, it should have either free electrons or it should have free ions. If you talk about the solid state, of your ionic solid NaCl, my dear students, what will you see? It is fixed. Every position is fixed. There are no free ions present there, right? Yes. So in the solid state, no free ions are present. But if you talk about their molten state or their aqueous state, it's better you say aqueous state here. So if you talk about their aqueous state, what will happen? In aqueous state, your Na, what example I took? NaCl. So if I talk about the aqueous NaCl, you will have ions in the aqueous state as Na plus Cl minus. That is, you will have free ions present in the molten or the aqueous state. Since you have free ions, they will carry charge and they will act as good conductors of electricity or heat. if we talk about heat, but majorly we talk about the electricity here. So they are good conductors of electricity because free ions are present in the molten or the aqueous state. But in the solid state, your Na plus and Cl minus are rigidly present on their positions. So no, my dear students, free ions are present to carry the charge, and that is why it is a bad conductor in the solid state. Okay, yes. These have a very high melting point. Next point is they have very high melting point. They have very high melting point because they have very strong forces of interaction. Okay, yes. These are the few points which you need to know about the ionic solids. Okay, yes. I hope you're clear with this. You can write each and every part we have discussed till now about ionic solids. Write it down, my dear students. Next. 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 Okay, perfect. So my dear students, let's end our session today here only. We'll discuss about the different types of solids in the next class, and we'll start our calculations. We'll calculate the point, what are the points in a solid state. We'll discuss a lot of things about the crystalline solids more as well, and the rest of the types of solids as well. So I hope you enjoyed today's session. Today's session was very easy and very theoretical, so you need to go through the theory. Your homework would be you have to go through the NCERT's starting part of solid state. That is a theoretical part, and you need to read that part from the NCERT. Only then you will be clear about all the types of solids and their interactions. We'll continue our session in the next session. Till then, keep studying. All the very best. Thank you so much.